Yes.
Can you see my whiteboard?
No. It's loading.
Can you see it now?
Yes.
Okay, let's say I have an element represented by X. I know that this element is associated with its atomic number. Atomic number, it is denoted by Z, and nucleon number or mass number is denoted
Okay.
by A. That means if you want to represent an element, it is represented by this thing, A and Z. A shows the mass number and Z shows the nucleon number. So what is an atomic number? What do you mean by atomic number? You might have studied in chemistry as well.
The protons and neutrons.
Just the protons. Atomic number is defined as number of protons in the nucleus.
Okay.
Okay. And what is nucleon number and mass number? Proton number plus the
number is the proton plus neutrons.
protons plus neutron. Okay. And if there are number of protons, let's say 14 number of protons, then there will be equal number of electrons as well. Okay. Until and unless the element or the atom is ionized. Ionized means the equality of proton and electron might get disturbed, or might be they becomes unequal when they becomes ionized. Okay. But usually the
Okay.
number of protons and electrons are always equal. Okay.
Okay.
For example, if I'm saying uh, what is the atomic number? Element is carbon, let's say. What is the atomic number of carbon?
Carbon.
This is carbon, for suppose. Number
6, sorry.
6. And what is the nucleon number or mass number?
We add them.
In this particular example, according to the labeling, tell me the atomic number and the mass number.
Okay.
What is atomic number?
Is it 6?
And mass number?
We add them, right? 12 plus 6.
Why 12 plus 6? Mass number is 12 only. Because A represents the top thing represents mass number. So mass
Oh,
number
okay.
will be 12. And I know that mass number is neutron. So if you want number of neutron, how you
Minus 6.
get is 6. Okay. So this, if it is asked to write down the structure of this carbon 12 and 6, what you will write? It contains 6 protons and 6 electrons and 6 neutrons. Clear?
Okay.
Okay, Paul. Then I am giving you one example. You have to tell me that how many protons, electrons, and neutrons.
And which one?
Copy this whole thing that is written on the board.
Okay.
Done?
No.
With the help of those recordings, now you will be able to um, do your.
Okay.
Done?
1 minute.
Okay, please make this head picture. Nuclei. Done?
Yes.
Did you make this heading nuclide notation?
Yes.
Okay, so if we are talking about this carbon, it contains 6 protons, 6 electrons, and 6 neutrons, right?
Yes.
Okay. Do you know about isotopes? Do you know about isotopes? What is it?
They have the same number of protons but different number of neutrons.
Same number of proton but different number of neutrons. Okay. So this example, does this carbon isotope 6 neutrons, 6 electrons?
No.
Is it? No, it is not an isotope because all the things are equal to each other. Okay. So let's say I have this element, iodine. Iodine is represented by I. Okay. Find its mass number, atomic number, neutron number. And please do it over here on the whiteboard. Yes, you are here, Manal.
Yes.
Please do it on this whiteboard.
Um, it's 53 atomic number.
Just write it down.
Okay.
It was correct. Atomic number is this number. That was correct. Atomic number is the proton number.
For
Mass
mass
number,
number, we have to add both.
it's written on in the nuclide notation. You don't have to do any calculation.
Okay. It's 53.
No.
Oh, sorry, 131.
Yes, it's 131. And how many electrons will be there?
Electrons minus. No. Minus it.
No, I told you something about with the yes, please write down. Okay, now tell me proton number and electron number are they equal? Proton number and electron number are they equal?
Yes.
And what about neutron number? Is it
No,
equal?
neutron number isn't.
So this iodine, which is 53 131, is an isotope. Isotope of iodine.
Okay.
Okay. And because it contains this much of neutrons in the nucleus, so this can emit out radioactive emission.
Okay.
Okay. Because its nucleus is very heavy because of these 78 number of neutrons, due to which it can emit out the radioactive emission in the form of alpha and gamma. Clear?
Yes.
Any problem?
No.
Okay, then coming towards half-life. This is the most important topic of the radioactive emission. Is there any confusion in alpha, beta, gamma emission in structure of atom, in nucleus and all things? Please let me
No.
know so that I can proceed on to half-life.
No.
Okay, as you know that unstable nuclei that contains more number of neutron and the nucleus that are considered to be the heavy one. Okay, they are emitting out the radioactive emission, right? So
Yes.
when they are emitting out the radioactive emission in the form of alpha, beta, and gamma, basically the nucleus is emitting out the radiations. So that nucleus from instability start becoming stable. That nucleus is actually becoming stable after emitting out the radiations due to instability. If nucleus is keep on emitting the radiation, its mass reduces. It starts becoming stable, and then a point will come, then it will start decaying,
Okay.
means it will be vanished. Okay, when it keeps on emitting out the radiation in order to be in the process of half-life is actually the measurement of the time in which the unstable emitting out the radioactive emission. It is the time required by half of the unstable nuclei to become stable after emitting out the radioactive emission. Please write down the definition in your notebook. What is half-life? It is the time required. It is sorry. It is the time required by half of the unstable nuclei. It is the time required by half of the unstable nuclei
Okay.
to become stable. To become stable.
Can you repeat it?
It is the time required by
Okay.
half of the unstable nuclei
Okay.
to become stable.
Okay.
Okay, why we are counting the half of the unstable nuclei? Why not the full unstable nuclei? This is so because radioactivity is a random process. Random process because of direction, time, and which nucleus is decaying. I don't know. What does this mean? Radioactive is a random process in terms of direction, in terms of time, in terms of which nucleus is decaying at which time. What does it mean? First of all, when we are saying that this atom is, let's say, radioactive, what do you mean by this thing? If I am saying this atom is radioactive, what do you mean by this thing?
Is it the neutrons is more?
Neutrons are more, due to which what will happen?
Radioactive emission.
In the form of alpha, beta, and gamma, right?
Yes.
Now, I know that this atom does not contain only, if we are talking about an element is made up of number of atoms, right? Atom 1 for suppose, atom 2, 3, 4, 5. Okay?
Okay.
If we are talking about an element, it is made up of so many number of atoms or molecules. If we are talking about an element, right? And each and every atom has its own nucleus. And each and every nucleus has their own number of neutrons, due to which this element becomes radioactive. Okay. Now, I don't know that if radioactive emission is going on, then which atom's nucleus is going into the decaying process. I don't know. It's a random process. I don't know that atom 1 is emitting out the radiation or atom 2 or atom 4, 3 or 5. Okay. I cannot find it out. That's why the radioactive process is considered to be the random process, because I don't know that at what time which nucleus of an atom is undergoing into the radioactive decay process. Is that clear?
Yes.
Okay, so please write down in your notebook that radioactive emission is a random process. Radioactive emission is a random process because
Okay.
we don't know we
Okay.
don't know at what time we don't know at what time which
Okay.
nucleus of an atom we don't know which nucleus of an atom
Which nucleus atom?
of an atom
Okay.
is undergoing
Okay.
into a decay process.
Okay.
Okay, number one. Number two,
Okay.
in terms of direction. Okay, look at here. Let's say I have this atom which is unstable. Its nucleus is keep on emitting out the radiation. Now I don't know that in which direction, north, east, west, south. I don't know in which direction the radioactive emission is going on. If an atom is kept over here, it can be in the north direction, it can be in the northeast direction, it can be in the west direction, it can be in the south direction. So radioactive is a random process in terms of direction, because we don't know that in which direction the radiations are emitting out. Clear?
Yes.
So add to your description that radioactive is a random process
Okay.
because we don't know that in which direction
Okay.
the radioactive emission is taking place.
In which direction the radioactive?
Emission is taking place.
Okay.
Okay. Similarly, I don't know that at what time, after 2 minutes or 3 minutes, this atom is emitting out the radiation. Okay. I don't know the exact time, that at what time this atom is start emitting out the radiation. Okay. It could be possible that it takes 1 hour, it could be possible that it takes 2 days, it could be possible that it takes 3 years or 4 years. I don't know the exact time in which this atom is emitting out the radiation. It could be 1 minute as well. Okay. So radioactive,
Okay.
add the third point to your context. It is a random process because we don't know the exact time. It's a random process because we don't know
Okay.
it's a random process because we don't know the exact
Okay.
time
The exact time.
in which the nucleus is sorry, in which the radioactive decay process is taking place.
Takes place. Okay.
At what time the radioactive emission is taking place. Okay.
Okay.
And lastly, radioactive emission is a
Okay.
spontaneous process. Radioactive emission is a spontaneous process because it does not depend on physical condition. Whether there is a cold atmosphere or hot atmosphere, dark room or light room, high pressure or low pressure region, it does not depend on the physical condition of the atmosphere.
Okay.
Radioactive process is a spontaneous process. Write down.
Okay.
It is a spontaneous process because it does not depend on the
Depend on the.
external environmental conditions. External environmental conditions like temperature, pressure, etc.
Okay.
Okay. So that's why radioactive emission from any unstable nuclei is considered to be a random because of their direction. Which nucleus is emitting out the radiation, I don't know. In which direction it is emitting and during the decay process. Time will come that when it keeps on emitting out the radiation, it will start decaying and becomes zero.
No.
So because I don't know the exact time in which the atom is going into the decay process, that's why the scientists have decided to measure the half-life of the atom. Half-life means the time in which the half of the atom, unstable atom, becomes stable. For example, first of all, tell me how you will measure the radioactive emissions that are coming out from the substance. Is there any instrument through which I can measure the radiations, the count?
The GM tube.
The GM tube. Good. So basically, we are using the GM tube in order to find out the half-life. Now, how I will find out the half-life that contains an unstable nucleus that is emitting out the radiations, okay? Or I can say an active source. Is that clear?
Yes.
When this tube is placed, for suppose, in front of this radioactive source, let's say $1,200 in order to become 600, that means the first half is known as its half-life. Now, this half-life can be in 1 minute, can be in years, can be in days, can be billions and trillions. Then its further half will be 300. So that will be its second half-life. Is that clear?
Yes.
300. Okay. Then 300's half is 150. So that will be its will be, and then 75's half will
Okay.
be in decimals. So we will stop over here. We will say that now